Mark mentioned that the power and cooling are redundant. So what I'm going to do is simulate a blower failure just by pulling it out a little bit, and then you can see how SMH picks it up, and you can see that it doesn't cause the system to crash. Assuming that I check and make sure that I'm not showing you what happens when there's two blower failures. So I'm going to first go do that.
So, well, really, kind of to start out with, so we talked about all of the hardware parts and that. The next stage is, you know, how does the management tools talk to the system? So, I mentioned SMH, so we have our system management homepage here. And through the system management homepage, we can get a lot of information about the system. So, where we're at right now is on the hardware listing. So this is showing our 4 cabinets, all of the cell blades online, right? It's showing all of the I/O chassis installed. Then we have 2 partitions, the green partition, the blue partition. And it's showing which I/O is connected to which cell. So you see the physical connections that are going there. Okay? And I'm gonna have to drive. Let's look at a little bit more on the end part. We could actually go in, if we wanted on this, through this system, we could actually manage the complex. So I promised Mark I wouldn't do it. But you can see, we could actually go in, you know, and if I wanted to do something, I could actually deactivate this cell offline, right here. So you see I had selected that cell, and it opened up the opportunity to perform a function here, okay? I could have just as well done that here with the, you know, the I/O. You know, I could go ahead and deallocate the I/O. I can actually go in and target a specific I/O cell or I/O slot. So if we look down in here in the I/O, you know, I could turn on the LED chassis to show it flashing, make sure I got the right one, or I could actually add a card in, that type of stuff. I could replace the card. So I'm not going to change any of those. But Mark went to go check on the power and cooling. So when you look at the power and cooling, we get a reporting of the whole system back. So you see we got cabinet 0, cabinet 1, and then you look, we got the 4 blowers up here, 4 blowers there. We got our I/O fans. We got our power supplies here, right? So everything's reporting back in that it's okay. So 4 okay, no failed, right?
So you might want to hit refresh.
Did you actually do it?
I did it.
Okay. So
sometimes it takes a little while. There you go.
And so we have 3 okay and 1 that's actually been removed. It's not reporting failed, but it's not there. So it's being said, it's being told, look, I'm not reporting one of the blowers. And so he's actually took out 1, which should be the front right one. Okay, and so when he goes and pushes that back in, we'll see that we'll go back to getting 4 in that specific cabinet. Okay, so he's popped it back in. Let's see how quick it is. So it's already reported back that the blower's back in, and one thing to note is that this will not actually report good until the speed has been detected to be at a certain RPM. And there are thresholds that have been set for all of the blowers and all of the fans in the unit. So if a fan is still spinning, but is spinning too slow, it could still report as failed. And so you got a lot of different systems. So I'll go back here to the partitioning page.
Command line equivalents of all this?
Command line, yes. Yeah. So when you say command line equivalents, there's no command line equivalents for saying report that a blower has failed. But if a blower has failed and you're not running the system management homepage, the event logger will log the event, record it, and store it, and it'll be reported. So if you go into the console and you report events, it would be there.
But I can't just say, show system status, and it shows me all the components, and yes, no?
Yes. Yeah. You can do that both at a complex level, at a partition level, at a virtual partition level, and so the command line equipment, that's all I live with. So I don't really use this.
Can we see it?
I don't
If you have time, I don't want to derail the schedule.
Can we get console? Can we get console on the box? Is it booted?
Yeah. You want me to?
They wanted to see the command line equivalent of some of the reporting here, so I was going to just run par status.
You're running an HPUX on this thing.
Right.
Now it's par status to everything that he just said.
Par status will report back the complex information, the individual partitioning information. You can pass attributes to decide what level you want. If you just want to know, if you want verbose, you do a -V and it dumps everything. If you just want to get the cells,
Your root.
thank you. So, we can run par status -C. This shows me the complex level of the system and how it's laid out.
That's better.
Okay, so you can see in here, it's showing that I've got, that I'm cabinet 0, cell 0. I've got 8 CPUs okay. None of them been deconfigured, and I can assign 8. I got 48 gigs of memory. In this case, we have deconfigured memory. They've been doing testing with this unit, so they've actually are taking memory in and out. It's showing that you're connected to cabinet 0 bay 1 IO chassis 3, telling you which specific IO chassis got that ring IO cable connected. It's saying that it is core cell capable. It is. You can decide if you want to. If a cell fails, you can decide if you want to use it on boot on the next try, or you can set a policy that if it fails, go ahead and deallocate it if the system has to reboot. So you can set policies like that. You can see we got the first 8 cells here are for partition 0. Next 8 cells for partition 1. Okay. The verbose command is done at each partition level, so we'll do P0. And you see in here, I'll scroll back up. So this is telling us right here that I've got partition 0. It's an active partition. What's my primary boot path? What's my alternate boot path? What's my HA boot path? What the PDF rev code is? What the cell architecture is? So Titanium.
Now, all processors on a single cell are going to be identical, right?
They will all be of the identical speed and
right. I mean, that's why.
Type. Yes.
This is only one cell, but it's saying that it's Titanium.
No, this is all
so.
8. This is all 8 cells for the partition.
Oh, okay. Okay.
So when you create a partition, they must all be the same type. So that's why we said if you have a PA and an IPF, they can PA system. It can exist in the same enclosure, but you can't have PA components and IA integrity components in the same partition.
But what if you had Titanium 1.4 and 1.6? Can they exist in the same partition? This almost suggests no.
Well, this is just going to give you a summary output for the speed. You can get CPU level information for the partition as well. And I don't typically dig into that. We could probably pull Mark back over. He might be able to ask.
It wouldn't really be a best practice anyway to have mismatch.
Generally, they're all speed bins are the same. So, but it's a good question. I might be able to mix them. I'm not the right person to say.
Don't worry about it.
Chips and the cell have to be the same, right?
The what?
Chips and the
They have to be. They have to be the same. Yeah, they have to be the same chip. I just wasn't sure about the.
They had to be the same speed too.
Yeah, I was thinking. I mean, even if you could have them different speeds, it would be really dumb to have, because you would throttle everything in the partition down to the lowest.
I want to say they get all pulled down to the lowest one that's in there. But
so even if you could do it, would
I'm
be
not sure what
stupid.
to tell you.
Yeah.